Welcome to Online Algebra 2. Today, we will cover section 1-6, absolute value equations and inequalities. So our objective for this section is to write and solve equations and inequalities involving absolute value. And an absolute value quantity is non-negative. That's the definition, right? The way we find absolute value is the distance from zero. So it cannot be negative. Since opposites have the same absolute value, the same distance from zero, an absolute value equation can have two solutions. Okay, so again, the definition of absolute value of a real number written with my absolute value signs, that looks like that, is its distance from zero on the number line. So if you think about the absolute value of 4, it's 4 spaces away from 0, so the absolute value of 4 is 4. The absolute value of negative 4 is also 4 because it's still 4 spaces away from 0. The formal algebraic definition looks a little different because it says if the thing inside the absolute value is greater than or equal to 0, these two are the same. If the thing inside the absolute value is less than 0, then it's the opposite of x. Probably thinking, well, it's weird that a negative comes out of an absolute value, but it's really not. We're taking this thing that's inside of the absolute value and we're changing its sign if it is negative. For an absolute value equation, the variable within the absolute value signs, for example, like that, if the variable's inside, the value of x can be two solutions because both 5 and negative 5 have an absolute value of 5. So when we are solving absolute value equations, the way we're going to go about doing it is by isolating the absolute value and then considering both cases. Well, the inside of here could be a positive 5 and then these two would be equal. Or the inside of here could be a negative 5, and now when you take the absolute value, these two things are equal. So really what we're doing is when we get rid of the absolute value signs in an equation, we just consider the positive and negative case. So let's look at this one first. What's the solution of the absolute value of 2x minus 1 is equal to 5? So before we start, we say, is the absolute value term, is the absolute value symbols by themselves? And in this case, they are. So that means inside of here, inside the absolute value signs, for this equation could be true, inside the absolute value could be equal to 5. Or inside the absolute value signs could be equal to negative 5. Right? Because then once you take the absolute value, either one of these would be equal to 5. Okay? And then what we do is we just solve them both separately, and then either one could be the answer, right? One or the other one. Okay? So we just solve both of these equations separately. 2x is equal to 6. Divide out the 2, and so x could be equal to 3. Or add 1 to both sides here. 2x is equal to negative 4. Divide out the 2, and x is equal to negative 2. Both of those could be the answer. Yes, you can get negative answers for an absolute value equation, right? If we check it, if we want to check these things, which we're going to have to do and you should do here, you can see that if you plug negative 2 in there, negative 2 times 2 would be negative 4, minus 1 is negative 5. Then we take the absolute value and we get that the solution is 5. To graph them, they're just both points on the number line. So we just put a dot at 3 and at negative 2. Later on, we'll do an inequality where we're going to cover up, where we're going to make an arrow. But for now, an equation, right, we're just getting specific, discrete solutions. Let's try the next one, the guided problem. Okay. So again, we separate this into two separate equations. one of them with positive 4, and the second one with its opposite, negative 4. Right? And we're saying the thing inside the absolute value, 3x plus 2, could be positive 4, could be negative 4 for this equation to work. And really, by getting rid of the absolute value signs, we have to just consider both cases. Subtract 2 from both sides, and we get a fraction, which is okay. Subtract 2 from both sides, 3x is negative 6. Divide out the 3, and so x is negative 2. And we just put a dot at negative 2, and 2/3 is almost 1. And there's my two solutions. All right, so what about multi-step equations? Okay, so to solve a multi-step equation, the first thing you do is isolate the absolute value, then split it into your two cases, then solve for x. Okay, so here's my first step. I'm going to add 1 to both sides. And we get 3 times x plus 2 is equal to 9. Now you might be tempted to try to distribute the 3, but we don't want to do that, right? You don't want to put anything inside the absolute value, right? You just want to get the absolute value by itself. So let's divide out the 3 from both sides. And now we have the absolute value of x plus 2 is equal to 3. Now we can say that x plus 2 is 3, or x plus 2 is equal to negative 3. Subtract 2 from both sides, x is 1. Subtract 2 from both sides, x is negative 5. Graph it, we got a 1, and we got a negative 5. Okay. So again, isolate the absolute value, get the absolute value, the things in the absolute value, get that by itself first. Then split the equation into two separate cases, the positive and the negative case, then solve for x. Let's try our got it problem here. Same idea. We're going to start by subtracting the 3 from both sides. 2 times x plus 9 is equal to 4. Divide out the 2. And now that the absolute value is by itself, I separate it into two separate equations, positive 2 or negative 2. Subtract 9 from both sides, and we get x is negative 7, and x is negative 11. So we have 7, and a little bit further, 11. Okay. So distance from 0 on a number line cannot be negative. That is the definition of an absolute value. Therefore, some absolute value equations, such as the absolute value of x is equal to negative 5, have no solution. It is not possible. So, what does that mean for you? It means that you need to check your answers to be sure that they both work, because one or more possible solutions may be something called extraneous. Extraneous solution is a solution derived from an original equation that is not a solution of the original equation. It's just a solution that you get, but it doesn't actually work. Now, if you notice, this equation has something different from the previous equation. When we look at this, we only had one variable on the left-hand side. And even in problem 1, one variable on the left-hand side. But now, if we look at this problem, we have two variables, one on each side. If you have two variables in an absolute value equation, you must check your answers. You should always check your answers, but we have to check our answers here because it's possible that we can introduce extraneous solutions. One of the solutions might not work. Okay, when I look at this problem, the absolute value is by itself. So I'm going to say that 3x plus 2 is equal to the positive or 3x plus 2 is equal to the opposite of both. Okay, so be sure you change the sign of everything on the right-hand side. Really what we're doing is we're taking the opposite of the whole right-hand side. So we're doing for kind of like that, the opposite of everything. Okay, but I usually like to just do it in one step. So let's solve both of these. So in this case, I'm going to subtract the 3x from both sides in order to keep x positive, just to make my solution a little bit, or my equation a little bit easier. So we get negative 3 is equal to x over here. Again, you have to distribute this negative. All right, and now I'm going to add 4x to both sides in order to keep my variable positive. You don't have to do this. I just think it's a little bit easier to try to keep the variable positive, less chance of making a mistake. And so x is equal to negative 1. All right, so we have two solutions, negative 3 and negative 1. In order for our solution to work, the absolute value of 3x plus 2 has to be equal to 4x plus 5. So if I plug negative 3 in first, that gives me negative 9 plus 2, absolute value of that is equal to negative 12 plus 5, which is negative 7. Already, that is a big red flag because the absolute value of something cannot equal a negative number. And when we look at here, we have negative 7, but it's the absolute value of negative 7. So the absolute value of negative 7 is positive 7. So this does not work. Okay. Now, don't just assume that the next one's going to work. Let's check that one as well. So we have absolute value of negative 3 plus 2 is equal to negative 4 plus 5. So that's the absolute value of negative 1 is equal to positive 1, and that is true. All right. Let's try our got it problem. And same idea. So we say that 5x minus 2 is equal to 7x plus 14. And 5x minus 2 is equal to a negative 7x minus 14. I'm just going to change both of them right away. Okay. Smaller variable to the bigger one keeps the question a little bit easier. 2x plus 14. Subtract 14 from both sides. That's a negative 16 is equal to 2x. Dividing out the 2 gives me a negative 8 equals x. Okay, so we could check it now, but I'd rather get both answers first. Let's add 7x to both sides. So that's 12x minus 2 is equal to negative 14. Add the 2. 12x is equal to negative 12. So x is equal to negative 1. All right, let's see which one of these works. I'm just going to check the right-hand side first. So negative 8 times 7 is negative 56. So this is a negative. So this is not going to work. We cannot have the absolute value equal to a negative. The right-hand side can't be a negative. With negative 1, it is a positive 7. Negative 7 times negative 1 is negative 7 plus 14 is 7. And then if I plug negative 1 in here just to double check, we get a negative 7, which works. Okay? So the point of this problem is always check your answers, especially if you have a variable on both sides for absolute value equations. All right, so let's talk about absolute value inequalities. The solutions of the absolute value inequality include, for x is less than 5, includes values greater than negative 5 and less than positive 5. Right? Think about it. So if the absolute value has to be less than 5, absolute value negative 4 is positive 4, which is less than 5. So all of these numbers work and all these numbers work. And if we look at it, it looks like a and inequality, where the middle, the part that is overlapping, is my solution. So I can rewrite this as a compound inequality as x is less than, so if my absolute value inequality starts like this, the way I make it into a compound inequality is I say that x has to be less than 5, and look at the opposite, x is greater than -5. So really what you have to do is when you take the negative sign, when you look at the negative case, you also have to reverse the sense of the inequality. And there's a little trick to sort of remember that this is going to be an and inequality as opposed to an or inequality, and it just comes from a little mnemonic device of saying this sign in a slow and deliberate way, like less. It's a less than inequality, less than. So there's an and in there, so kind of right if you think about it. Less than inequality sounds a little weird, but it actually works. This trick though of, well, I don't want to put an equal sign there. This trick of starting with the one that you see, and in the negative case, reversing the inequality works either way. But this is going to be an inequality, so we're going to have two graphs that overlap, and that will be my answer. Okay. So let's try it. Steps are still the same. Isolate the absolute value. Thankfully, it's by itself. This is a less than, so I know it's going to be an and inequality. So I'm going to start with 2x minus 1. It's less than 5. And 2x minus 1 is greater than -5. Okay. I could also write this as a compound inequality if I wanted to, with since 2x has to be in between -5 and +5 for this absolute value to be true. I can rewrite it with, I could collapse these two things and write it that way, kind of like this, that we just say -5 is less than, or sorry, -5, yeah, is less than 2x minus 1, which is less than 5, because 2x has to be in, 2x minus 1 has to be in between those two numbers, and I can solve it that way as well. But let's stick with stick with this one. Add 1 to both sides. You have 2x is less than 6. Divide out the 2. Remembering, of course, that if this happened to be a negative, we still have to reverse the inequality signs. But it's not, so I can start there. 2x is greater than -4. Divide out the 2, and x is greater than 2. So I have my two boundary points, 2 and 3, sorry, -2 and 3, right? And my solution is going to be all the numbers between them, because this is an and inequality. And you can double check that, right? Right, greater than 2, so it should go this way, less than 3, so it should go this way, and that's where they overlap. Let's try one more of those. Let's actually make this with a compound inequality. So I'll set it up the first way as well. So we have 3x minus 4 is less than or equal to 8, and 3x minus 4 is greater than or equal to -8. When you take the negative case, reverse the sense of the inequality. Let's make a compound one though. So -8 less than or equal to 3x minus 4 is less than or equal to +8. So now I can solve this by adding 4 to all three sides, to all three parts, which then gives me -4 is less than or equal to 3x, which is less than or equal to 12. Divide everything by 3. We get a fraction over here, that's okay. So -4/3 is less than or equal to x, which is less than or equal to 4. So that means we have a solid dot at 4 and we have a solid dot of -4/3, which is a little bit bigger than 1, and my answer goes between them. All right, so if the less than was a and inequality, then the greater than is an or inequality. It's going to be outside the interval of -5 to 5. Okay, so we can say or. And if you say it really slowly again, great or than. So there's an or in there, kind of. Okay, a little bit easier to see greater than as an or than a less than as an and. But it helps. All right, but the way we can actually go about solving this is going to be pretty similar. So we take the positive case, 2x plus 4 is greater than or equal to 6. And then when we take the negative case, I say greater than, so I know it's or. So when I take the negative case, I take 2x plus 4, and I change the sign of the inequality, change the sense of the inequality when I look at the opposite case. I subtract 4 from both sides to solve this. So 2x is greater than or equal to 2. So x is greater than or equal to 1. Subtract 4 from both sides. 2x is less than or equal to -10. So x is less than or equal to -5, right? Remember, of course, if I divide by a negative, which I didn't, I should change the sense of the inequality again if I have to. And now these should go in different directions. So we have a solid dot at 1 and a solid dot at -5. And we go to the left there, or to the right there, and to the left there. Okay. Let's try another guided problem again. So again, and with or inequalities, you cannot combine them into one compound inequality. So we're going to have to do these separate both times. 10 is greater than 15. Greater than, that's an or. 5x plus 10 is less than -15. Subtract the 10, and we get 5x is greater than 5. So x is greater than 1. And subtract 10. 5x is less than -25. So x is less than -5. Circle there. Circle there. To the left. Or to the right and to the left. Now, what would happen if this looked like this? Now, this would turn into an and inequality. And you would now see that there's nowhere that these two cross. Actually, let's think about that for a second. So this would be a, these two would flip this way. Yeah, okay, then the answer would just be right in the middle. I was trying to think of a way that we can turn this into an undefined solution, but that didn't work. So move on. All right, so our three situations here is if we have an absolute value equal to A, we would get these two answers. If it is less than, it would be in between those two solutions. If it's greater than, it would be to the left and to the right. Okay. Last thing we can look at is something called tolerance. So a manufactured item's actual measurements and its target measurements can differ by a certain amount, called tolerance. Tolerance is 1/2 the difference of the maximum and minimum acceptable values. And this is just a fancy word to rewrite an equation using an absolute value equation for a word problem. Okay. So in car racing, cars must meet specific dimensions in order to enter a race. Officials use a template to ensure these specifications are met. What absolute value inequality describe the height of the models the race car shown with the indicated tolerance? So this is what you want. You want your car to be, let's use a different color. You want your car to be 52 inches. Okay. you could have it this or this, anywhere in between those two. So if I was going to calculate the tolerance, right, the formula for tolerance says half of the difference of the maximum and minimum. So basically, we're finding the middle of the max and the min. So if we take 53 minus 51 divided by 2, we get 1 inch. Okay? That means that the actual height of the race car has to be within 1 inch of 52. So it could be 51 or 53. So that means that my equation, right, that the height has to be the height minus 52. Right? If it's 53 minus 52, that's a positive 1. Or if it's 51 minus 52, that's a negative 1. The height minus the midpoint has to be somewhere in between negative 1 and positive 1. When I have a situation like that, I can write it as an absolute value equation, and I would use less than because I want it to be in between, right? I want all the answers to be in between negative 1 inch and positive 1 inch, so I could rewrite it like that. Okay? Just a little problem to help you realize that we can actually use absolute value equations for something besides just distance. Okay, so again, make sure that you realize that especially in this question right here, you must check both of your answers, okay, to check for an extraneous solution. And how do I know that? Because it has the variables on both sides. Okay, so that was 1-6, absolute value equations and inequalities.